John Dalton's atomic theory is one of the most important milestones in the history of science. In the early 18th, Dalton had chemistry structure, helping to explain many mysteries of the time. How matter behaves, how it changes chemically, and why it can never be created or destroyed. The main point of Dalton's atomic theory are simple but powerful. All matter and elements are formed by indivisible particles called atoms. Atoms of the same element are identical, while atoms of different elements are distinct. Atoms combine in simple whole number ratios to form compounds and mixtures. Chemical reactions are not creation or destruction of matter, but rearrangements of atoms. And finally, when elements form more than one compound, their ratios differ by whole numbers, a principle Dalton called multiple proportions. This framework explains key chemical laws. For example, the idea of rearranging atoms clarifies why the mass of matter is always conserved during a reaction. Nothing disappears, atoms simply reorganize. To build his theory, Dalton used the scientific tools of his time, precise balances, experimental data from other chemists, and his own logical reasoning. He even designed some of his own measuring instruments. His theory was both a logical conclusion and a leap of faith based on real numbers and experiments, but without direct proof, since atoms were invisible in his era. Dalton's idea also laid the foundation for stoichiometry, the science of calculating reactants and products. Take ammonia, for example. The reaction requires nitrogen and hydrogen in a fixed ratio, 1 molecule of nitrogen for every 3 molecules of hydrogen. If we start with 9 grains of hydrogen, about 4.5 moles, we need exactly 1.5 moles of nitrogen, which equals 42 grams. Thanks to the law of definite proportions, we know ammonia will always form in this ratio. The principle is not just theory, it drives the modern chemical industry. Knowing exact proportions guarantees predictable yields, consistent quality, safety, and lower costs. For chemical engineers, precision means avoiding waste, minimizing risk, and designing processes that can scale from the lab to global production. Dalton may not have seen atoms with his own eyes, but his bold vision reshaped science. His atomic theory connects experimental facts with a unifying idea, becoming the foundation for the chemistry we use every day. Thank you so much for listening, and God bless you.